Okay, now we're gonna start chapter 6, which is about factoring polynomials. In 6.1, we're gonna go over factoring out the greatest common factor first. Which we abbreviate by the GCF. Okay, so let's discuss the greatest common factor of a list of numbers. First, if we have numbers, how do we find the greatest common factor? Like 8, 12, and 36. Since we're looking for a factor, it has to divide 8, 12, and 36. So it has to be the smallest number or a factor of 8. The smallest number is 8 or a factor of 8. So what are the factors of 8? Starting with 8 itself, there are 8, 4, 2, and 1. You start with 8. Does 8 divide 8, 12, and 36 evenly? No, it just divides 8 only. Does 4 divide 8, 12, and 36? Yeah, so that must be the greatest common factor. So to find the greatest common factor of a list of numbers, you pick the smallest number, you list its factors, just like we did with the 8. You start with the number itself, then you go down until you find a number that divides all of them evenly. Now, if we have a list of expressions, how do we find their GCF? To find the GCF of a list of monomials, you want to select every common variable raised to the smallest exponent in the list. Raised to the smallest exponent in the list. So if in one monomial we have x, in the second we have x squared, in the third we have x to the 4, we pick x. We always pick the variable that's common to all of them with the smallest possible exponent. And then you multiply these to get the GCF. So for example, how do we find the greatest common factor of 7a squared b and 14ab squared? So we start with the numbers. We just did that. 7 and 14, the smaller is 17. 17 divides 14 7 divides 14 evenly, so it's 7. A squared and a, we get the smallest exponent. B and b squared, we got the smallest exponent, so it's 7ab, which is the GCF of these. Let's try another one. What is the GCF, greatest common factor, of 4a cubed b squared c, 12a b squared c squared, and 20a b squared c squared? Again, we look for the numbers first. 4, 12, and 20. 4 is the smallest. Does 4 divide 12 and 20 evenly? It does, so we pick 4. A cube, A, so it's A. B squared, B squared, B squared, so it's B squared. C, C squared, C squared, so it's C. So that's finding the GCF. Now, how do we factor out the greatest common factor? That's what we're about in chapter 6. We're factoring. So to factor out the GCF, we reverse the distributive property. So let me explain that. In chapter 5, we use distribute, and it's say 4x times x squared plus 2y minus 7. So we would distribute, so it'd be 4x cubed. 4x times 2y is 8xy. 4x times negative 7 is minus 28x. In chapter 6, we're going to reverse that. So if we want to factor out the greatest common factor, and we're given this, 4x cubed plus 8xy minus 28x. So the first step is to find that GCF, which is 4x, and then instead of timesing, we divide. So we divide 4x into 4x cubed, we get x squared, or we could do the reverse. We could say 4x, what do I times it by to equal 4x cubed? So I have to times it by x squared. And then 4x, what do I times it by to have 8xy? It's 2y. And then 4x times negative 7 would give me negative 28x. All right, more examples. Again, how do we factor out the GCF? 2y minus 10. 2 is the only greatest common factor, so 2 times y is 2y. 2 times 5 is 10. And then b cubed minus 2b squared. So we pull out b squared, the smaller exponent, and then it's b, because b squared times b is b cubed, minus b squared times 2 is 2b squared. Okay. Another example, again factor out the greatest common factor, 32xyz plus 48x squared yz plus 36x y squared z. So we first find the greatest common factor, 32, 48, and 36. 32 is the smallest. It doesn't divide 48 or 36, so it's got to be a factor. 16 doesn't work. 8 doesn't work. I think 4 is the largest one that divides all of them evenly. X squared, x, so it's x. Y, and y squared, so it's y. Z, and z, so it's z. And then we're going to times this by 8 to equal that. We need 12 to make it 48. We need another x to make it x squared. Y and z are already there. We need a 9, because 4 times 9 is 36. X is there. We need a y to make it y squared, and that would be my final answer. Okay. Also in chapter 5, again, almost everything we do in chapter 6 is a reversal of what we did in chapter 5. So in chapter 5, we used to say distribute, and we have a negative, and then parentheses 3x minus 2y plus 4. If we distribute, we get negative 3x plus 2y minus 4. That changes all the signs of the terms inside. So in chapter 6, we're going to factor out the negative 1. So we're given this, negative 3x plus 2y minus 4. So we reverse it, we get negative, and then change all the signs. So when do we know to pull out the negative? That's always, we're going to factor out the negative 1, the greatest common factor first, including negative 1 if the first term is negative. So whenever you're factoring and the first term is negative, you pull out negative the greatest common factor. Okay, you pull out negative the greatest common factor. So for example, number 66, page 441 in your text, negative 25 x to the 4 y cubed z squared plus 30 x squared y cubed z4. So as soon as I see a negative in front of the first term, that's going to come down. The largest number that divides 25 and 30 evenly is 5, and then the exponents, x squared, y cubed, z squared, always the smallest exponent. So negative 5 times 5 would give me negative 25. This needs another x squared. Y cubed, I already have it. Z squared, I already have it. Now I need a 6 to make it a 30, but I need a negative because that's a plus. X squared, y cubed, I need z squared. Okay. The next, so this was the first factoring technique. The second factoring technique is group factoring. And group factoring, this should be used or thought of, should be used whenever we have 4 or more terms. whenever we have 4 or more terms. Okay, so for example, if I want to factor by grouping, and it's xy plus 3x plus 2y plus 6. I know there's 4 terms, and the first thing I should always look for is the greatest common factor. If there is a greatest common factor, you pull that out. Okay, so let's see the steps for grouping. This handout you have online again, so you can look at that. Decide if the terms have anything in common, which is the greatest common factor. If it is, factor it out. We don't have that. Group the first 2 terms together and the last 2 terms together. It's convenient to do this, but sometimes you have to rearrange if they don't have anything in common. Luckily, the first 2 terms have x in common. Factor out the greatest common factor from each of the 2 groups. In the second group, you have a choice of factoring out a positive or negative number. So x, y plus 3, you always pull that sign down. If it's a plus, you pull a plus. If it's a minus, you pull a minus. That's what that's about. Plus 2, y plus 3. The factors inside the parentheses are exactly the same. If they're the same, it's time for this 2-in-1 special. The one thing that the 2 groups have in common should be what's in parentheses. So you can factor out what's inside the parentheses, but only write what's inside the parentheses 1 time. If what's inside the parentheses doesn't match, you need to rearrange the 4 terms by trying again until you have a perfect match. If you have rearranged the problems a couple of times and still haven't had a perfect match, then it doesn't factor and we say it's prime. So we pull that out 1 time, and then we say this times what is going to give me the first term, so it's x. This times what is going to give me the second term, so it's plus 2. You may also write it as x plus 2, y plus 3. It doesn't matter. You can do either one of these, okay? And that's called group factoring or grouping. So let's look at some more examples. So factor by grouping. Bx plus bz plus 5x plus 5z. So again, the most convenient grouping is first 2 and last 2. So b is the common factor, x plus z. Again, you bring the sign down, plus 5, x plus z. The quantity inside the parentheses is the same, so we bring it down once, and then b plus 5. And if you want to check your answer, you just FOIL it. Okay. ax plus ay minus 2x minus 2y. Again, grouping. We pull the a out, so it's x plus y. And since this is negative, we pull the negative 2 out, and it will be x. And since we're pulling a negative 2 plus y is going to be negative 2y. So that's going to change the sign. Be careful. And then luckily we have the same quantity inside the parentheses, so pull it down once, and then a minus 2 is what's left. Okay, let's do more. 3xy plus 3xz minus 5y minus 5z. Again, grouping. So within the first group, we can take out 3x, so it'll be y plus z. Within the second group, we can take out negative 5, it's y, and then we change the sign because we pulled out the negative, so it's plus z. And then we pull that once, y plus z, and it's 3x minus 5. Okay. 3ab plus 9a minus 2b minus 6. So let's group them again, the most convenient grouping. So 3a is the common factor, and it's b plus 3a times 3 is 9a, and then negative 2. Again, b, we change the sign, so it's plus 3. Again, b plus 3, 3a minus 2 would be my final answer. Okay, example 5, a squared bc plus a squared c plus abc plus AC. Now this one has 4 terms, so obviously it's grouping, but there's a common factor to all of them. A is a common factor and C is a common factor. So we got to take care of that first. And it would be A, B plus A plus B plus 1. And now we do grouping. So A to B plus 1. The only thing we can pull out here is a 1, but it doesn't matter because we have B plus 1. So B plus 1, that leaves me with A plus 1. And then this has to come down and put up front. Okay. Now let's look at 100, page 441. Let's go to page 441, number 100. Let's see what that is. So 3x cubed minus 6x squared plus 15x minus 30. Well, before we do grouping, remember the GCF is 3, so we got to pull that out first. X cubed minus 2x squared plus 5x minus 10. Then we do grouping. This we can pull out x squared, so it's x minus 2. This we can pull out a plus 5, so it's x minus 2. Again, we bring that down once. X squared plus 5, and the 3 has to come all the way down. And that's the conclusion of 6.1. So we're going to stop that.